Hello everyone, welcome to our Automobile Engineering and Hybrid Vehicle class. My name is Samir and today we are covering Unit 1, the fundamentals of automobiles. This is the foundation for entire course. By the end of this lecture, you should understand what an automobile is, how we classify them, the typical layout and structure, the major engine components, different engine types and configurations, the working principles of 4-stroke and 2-stroke engines, and recent trends in engine design. So let's jump to the definition of automobile. Let's begin with a very basic question. What is an automobile? An automobile is a self-propelled vehicle. For those who don't know what is self-propelled means an engine-driven vehicle designed to run on roads and transport people or goods. It typically has wheels and engine for propulsion and systems for steering, braking and suspension. For example, cars, buses, trucks, motorcycles, all are automobiles. The classifications of automobiles. Next, let's look at how automobiles are classified. We can classify them in many ways, by fuel type, by purpose, by wheels and axles, by drive type. So in fuel type, there are petrol, diesel, CNG, LPG, electric, hybrid. By purpose, there are passenger vehicles, commercial vehicles, special vehicles like ambulances or tractors. By wheels and axles, there are two-wheelers, three-wheelers, four-wheelers, multi-axle trucks. And by drive type, there are front-wheel drive, rear-wheel drive, four-wheel drive, all-wheel drive. For example, you must be having a bike. Your bike is a two-wheeler petrol vehicle with chain drive. You must have traveled in a city bus. A city bus is a commercial diesel vehicle, often rear-wheel drive. Think about the vehicles you see every day in road. How to classify them? Pause and make a mental note. Let's go to the layout of an automobile. Layout means the arrangement of major components. Typical layout includes engine, let it be front, mid or rear. Next is transmission, the gearbox. Next is the propeller shaft in rear wheel drives, differential, wheels and tires, then the steering system, then the suspension system, then the braking system, then the body and chassis. For example, most modern hatchbacks in India have a front engine, front wheel drive layout. So let's go to the basic structure of an automobile. Let's break down the basic structure. First comes the chassis. It is the frame that supports all parts. Next comes the body, where passengers sit. It is designed for comfort and safety. Then comes the engine, which generates power. Then comes the transmission, which transfers power to wheels. Then comes the suspension, which absorbs the shocks. Then comes the steering, which controls the direction. Then comes the braking system, which slows or stops the vehicle. Then comes the electrical system, the lights, the battery, the wiring. They all come under the electrical system. Then comes the fuel system. It supplies fuel to engine. Then comes the cooling and lubrication. It keeps engine working safely. I'll give you a good example. Think of the chassis as the skeleton, the body as the skin, and the engine as the heart of the vehicle. Next, move to the IC engine components. Now let's go deeper into IC engine components. First comes the cylinder, the combustion chamber, where fuel burns. Then comes the piston, which moves up and down inside the cylinder, driven by expanding gases. Then comes the crankshaft. It converts the up and down motion into rotation. Then comes the camshaft. It opens and closes valves at correct timing. Then comes the connecting rod. It links piston to the crankshaft. Then comes the valves. It controls intake of air, fuel, and exhaust of gases. Then comes the flywheel. Smooths out the power. It smooths out the power, stores rotational energy. Let's quickly discuss each one. The piston is like a plunger. As fuel burns, it pushes the piston down. The crankshaft turns that movement into rotation, which eventually drives the wheels. The camshaft controls when the valves open and close to let in fuel air and expel exhaust gases. And the flywheel ensures smooth rotation by storing energy. Let's talk about the engine types and their configurations. Let's see engine types. By cylinder arrangement, inline. Inline cylinder arrangement. In inline, all cylinders are in a line. It's common in small cars. Then comes the V type. In V type, the cylinders are in a V shape. For example, V6, V8, they are in sports cars, mostly in sports cars. Then comes the boxer, horizontally opposed. It is used by Subaru, Porsche. Porsche you must have heard. Then it comes by cycles, the four-stroke engines and the two-stroke engines. Then it is also by fuel, petrol. In petrol, the spark ignition is there. In diesel, the compression ignition is there. For example, a Maruti Alto uses a small inline engine. A Ferrari might use a V8. Motorcycles may use inline or V configurations depending on size and power. The working principles of engines. Let's see how these engines work. First comes the four-stroke petrol engine. Intake stroke, air fuel mixtures drawn in. Compression stroke, the mixture compressed. The power stroke, spark plug ignites mixture, pushing piston down. Then comes the exhaust stroke, burn the gases expelled. There's one power stroke every two revolutions of the crankshaft. Can you name the four strokes again? Let me tell you. It's intake, compression, power and exhaust. Diesel engine difference. Diesel engines work similarly but with key differences. Air only is drawn in and compressed. High compression heats air. Fuel is injected and self-ignites. No spark plug is needed. Diesel engines are efficient, durable, but they are heavier. In two-stroke engine, the two-stroke engines complete the cycle in just two strokes. Intake and compression are combined. The power and exhaust are combined. The two-stroke engines, they are lighter and simpler, but less fuel efficient and more polluting. It is mostly used in scooters, small bikes, the chainsaws. The most recent trends in engine design. Finally, let's see the recent trends. Turbocharging. The smaller engines with high power. Direct injection, precise fuel control, variable valve timing, better for efficiency at all speeds, lightweight materials like aluminum blocks, plastics. Then comes the emission controls, catalytic converters, EGR, BS6 norms, then the hybrid systems, combining electric motors with IC engines. For example, modern cars often have small turbo engines that deliver power of a larger engine while saving fuel. Well, BS6 norms in India reduce pollution drastically. So let's jump to the final summary. Let's recap. We spoke about automobile, which is a self-propelled vehicle. It is classified by fuel, purpose, layout. In layout, there are engine, transmission, suspension, steering, brakes. In engine components, there are cylinder, piston, crankshaft, camshaft, connecting rod, valves, flywheel. The engine types are inline, V-type, and boxer. Four-stroke versus two-stroke cycles that you know. And in the recent trends, turbo, direct injection, hybrid systems. This concludes Unit 1, the fundamentals of automobiles. In the next class, we'll move to automobile subsystems, including cooling, lubrication, fuel, and ignition systems. Review these notes carefully. If you have any questions, note them down and ask in our next session. Thank you for watching. Stay curious and keep